What's up, everyone? Welcome back to Better Biomed. Today I've got the innards of a pump. We're going to open it up. We're going to show you how it functions, and maybe we're going to determine what some of the potentiometers are. I'm talking about the guts to a Plum 360 pump. There's a lot going on in this little cubicle right here, and if we know what each and every little thing does, then we're one step closer to being able to figure out a way to calibrate them ourselves. Now, I haven't had too much dealings with this particular type of pump throughout my career. Mainly it's been the Alaris pumps, B-Bron, stuff like that. But down here in Texas, there are a lot of these Plum 360 pumps that are all over the place. So this, dissecting it, should help give you guys a little bit better of a concept of what we're going to be trying to calibrate. So let's get right into it. Let's do it. All right, guys, here to help me contain any possible contamination, I have a silicone bay. That's what these things are so wonderful for. All my components will stay right here. If I create a mess, the mess is also going to stay right about here. So I have two examples of this pump. I have one that is contaminated and one that has been cleaned. When you take apart any of these Plum pumps, you have to be cognizant of where your fingertips are at all times, because there is goo that just emits from devulcanized rubber. You can see it here. See it up here on this? If you touch that, you will contaminate the rest of the plastics, and you will spend the rest of your hour cleaning the plastics, and it almost never comes off. So that's why I'm being very careful. This one here has not been treated or cleaned yet. I'm going to place it in there. It's still dirty. I have a clean example. And again, I'm going to check my fingers before I touch anything else, because these things will dirty up your clothing, your hands, your desktop, and the rest of the pump. So just be well aware if you touch something that you are leaving little black marks on. Ugh. You got to go and wash your hands immediately. Now you can see on this pump, there are some black lines on there, and that's after I was being very careful. It's that crazy. So just be wary of that. So this pump here, it's got a lever that activates this little front. It's got a little tray here that can pop on and off. And I'm going to just disconnect this guy right now before it gets ripped. There's a little ribbon cable. And let's see. I think we're good for all that. Now I'm just going to start taking some of the accoutrements off. I have a number 1 Phillips. Got just a regular flat blade. Hopefully this pump is not so corroded that it comes apart. And I need a bigger flat blade. Like this one here. Wow. There it is. It was definitely a wee bit stuck. All right, let's pull this guy off. Yuck. Now you can see where I'm wearing gloves. This pump has been wiped down considerably, and there's still goo juice up inside it. You see that? Pumps are not to be trifled with, folks. They are nasty, dirty, and they're just full of contamination. Full. All right, so now that I've got this little plate off, I would like to knock that pin out, and I believe it just comes right out. Could be wrong. It's got some goo juice on it, so my concept is to drive the pin and pop it out. Let's see, maybe I drive it this way. Nope. Denied. Does it drive that way? There's little ribs in this mat which kind of give me a little bit of a raised surface. Hold on, I need a little hammer. Let's go with the smallest hammer in my arsenal. Just a little tappy tap. There we go. That de-seated it. There we go. All right, so I'm going to set the pump up here on the corner. Give it some space. Let it release some of those emotions. Oh yeah, look at all the goo on that guy. Nasty. And I didn't think I was going to need any, but apparently I'm going to need some pliers. To help me with this, I got my wire stripper pliers right here. Come on. Oh, she's in there really good. It's almost ready to come out. I think just one more good tap. There we go. Out. So, mind you, all my tools and everything are going to stay right here because they are also now contaminated, okay? Be wary of that. It's something I don't even play with. So you can see this guy's now flapping in the breeze. I'm going to try to be a little careful so I don't rip any ribbon cables. There is a little Jesus clip right here, an E-clip. I'm gonna pop this guy off. Okay. And now this guy, I believe, should pop off. Oh, wow. Okay. So there is, again, a rocker that goes all the way through to the other side to here. And that means I have to prop the whole pump up again. And I'm using a rather large Allen. I'm just going to tap it. Okay. You can see it's coming out on the other side. And that is my entire swivel mechanism for this guy. I'm pretty sure there are better ways of doing this. And I'm pretty sure in the comments somebody's going to let me know, oh, you shouldn't have done it that way. Well, mind you, this is exploration. All right, there's a little tiny spring right here. I'm going to release it. Okay, there we go. The little spring is captive on a couple little legs. Now this guy's flapping in the breeze. The front comes off. Man, it gets nasty up in there. Whoever designed this pump, however long ago it was designed, there's so many areas that are recessed. You cannot clean them. Disgusting. Absolutely disgusting. And in fact, this part right here is very difficult to remove. And nobody is ever going to clean up inside here. And mind you, you can see the shmoo up in there. I've already cleaned this pump very heavily, very, very heavily with sandy wipes. I've used alcohol wipes. I use hydrogen peroxide wipes. I've used all sorts of different wipes on this already, and it is still contaminated. That's the scenario, guys. Okay. So I held the pin, and I pulled up on this guy. There is a little bit of grease on there. Interesting. There's a little slot right here that cams. What does it cam? Does it cam this guy? Let's see. Okay. Well, what does it cam on? There's a little bumper right there. I can see it. This guy here moves. Yep. So there's a little nodule right here that moves this guy. It articulates left to right. Just pops off. Nice and easy. There's a little bit of lithium grease on there. All right. Now that we're in, I can see what looks like a communications port. There's a ribbon cable right here. And there's some keepers on the sides. And now the front panel should be ready to come off. Nice and easy. All right. So, some things that I did not know before. There is a ribbon cable that comes down. There's some really tiny traces. I don't know why they made the traces that tiny, because that just makes them subject to easy corrosion. And they come down here, and there is a little button switch. It's almost like a membrane switch. And all that probably does is detect when a set is loaded or when the door is closed. Okay, right there. So if I were to pop this guy off, it looks like it's epoxied in. All you'd find is a little rubber button switch. Nasty. All right, let's see. I think I can set that guy off to the side now. All right, what do we have in here? We have pins. We got a bunch of different pins. And we have a large plunger. I have optical interrupter right here. You can tell when it's in its home position or when it's cycled. I'm trying to get this guy in there so I can maybe pry up on that, move it out of its position. There it is. Come on. Do it. All right, it's captive by something. We'll get down to it. I've got a couple little springy sprungs right here. This one and this one. Don't really know what those are for. And I have a couple different cams down here. This pump seems to be very over-engineered. I've got a couple ultrasonic sensors right here and right here. I do believe those are bubble detects. Could be wrong, folks. Could be wrong. But they look like they're ultrasonic. See them? Right here. Right here. And this guy right here, the reason I couldn't pop it out is because it's captive by this arm. So you gotta pop this arm off right here. And then this entire thing wants to come loose. Let's see, and I got this guy right here. There's a little rocker. And now I'm pretty sure that there are simpler ways to get this pump apart. Pretty sure about that. Okay, there we go. I got the rocker off. And I've got the arm off. And now I need this arm to let go of, there's an eccentric cam right here. You can see it. And that's what moves it up and down, or back and forth, rather. And come on. There we are. Okay. So here you can see the little arm with the notch for the cam. My gloves. Things are sticking to my gloves now. Okay. So now I can pull out that pin. You can see the cam right there. So this guy here rotates. Oh my gosh. The grease. Look at how it's sticking to my gloves. That grease is no go. So that grease is added drag on the system. There's some grease right here on the lip. And there's grease over here. That is going to drag on the motor no matter what. If you're getting accurate distribution from this pump, it's a wonder, because that is a lot of drag. That was gooey. Okay, let's see, I got tape up here. It goes to a ribbon cable. Let's see, let's just pull that tape off. I put this tape on here to keep that ribbon cable from coming unplugged. It's like a Band-Aid fix. And a wide ribbon cable. There we go. And notice how there's a ferrite core right here around the ribbon cable. Help cut down on noise. That's interesting. I've got a couple little flags right here. I don't know what these flags are for. They look, oh, wow, okay. I hope I can pull those apart. So those flags right there, they have little grids in them, and that's probably for an optical interrupter. So as they move past an optical, it counts like a pulse. I don't know how those work. We're gonna continue pulling it apart. We're gonna find that out. Never pulled one of these pumps apart. That's why I'm absolutely curious. That little shield just boogered off on me. There we go. All right. So you can see the shield right here. It's got two kind of delicate plastic retaining clips. There's another little spring down here, and that's why I couldn't pull it out. Pop that spring off. Man, that spring's going to be a pain to get back on too. Now, I don't know if this right here, it looks like the main driver for the pump. I don't know if it's going to be on a worm gear. I assume it probably is, because right there is that home position sensor, that optical interrupter that I talked about. It's very captive, so I'm almost thinking it's on a worm drive. That way there it can go back and forth without any play. Okay, let's see this side here. I've got another retention clip. I'm just holding this shield on. I'm going to try with 2 flat blade screwdrivers to get it out. I'm trying not to break anything. You know, some devices, as they get older, they get really brittle. I'm trying not to break it. I'm not going to ever use this pump again. It's just, you know, it makes for better content when it's not broken. There you go. So there's the retaining clip. What an over-engineered pump. So these are injection molded parts from the looks of it. But look at the detail of this guy. That's just crazy. All of that very complex part right there, just to hold in this optical interrupter, which, as I said, it detects the home position, I think. Go ahead and disconnect the ribbon cable. Yes. There we go. So if you have a pump that's airing when it cycles, you might want to try and clean this guy right here if any goo juice got up inside it. Alright, so this side here seems to be pretty trim and clean. I've got some more of these spring clips right here. You see that? Right there. Depress that guy. This whole assembly wants to pop out. Wow, that whole board wants to pop out now. Are we ready? So it looks like the board rocks out from the bottom. Nice and easy. I have some sort of assembly right here in the middle that might be keeping my board in. So let's see if we can pull that guy out first. Let's see, is that this one? Oh, I'm in luck. Score. A tiny little screw. I found the driver, the first driver I pulled out. Come on. That screw just got lodged up under there. All right. Over-engineered pump. Look at how tiny some of these pieces are. And you can see how this guy works. How it's got 2 offset springs. See that? Those are 2 springs that allow this guy to do this. It's weird. Very weird. Oh no! Okay, so the very bottom, there's a couple of these notches, and those notches seem to sit down on some spring-loaded contacts right down in here. Yeah, you can see right here and right here. Yeah, there's 2 contacts right there and right there. Whew. Who knows, man? Okay. And that screw is still down in there, man. that's arr. It's not cooperating. This is a complex little pump, guys. I would not want to pull these things apart for repairs. Just change the module. You see the fastener that was down through the middle of this. All right, and now this whole assembly is no longer captive. We should be able to pull it out. Got my ribbon cable right here. I don't want to damage it, so I'm just going to release it. There we go. So that's the ribbon cable, the main ribbon cable. And I noticed that there's one more interconnect cable right here. You can see I'm touching it. That does not look good. I also have two of these little clips. I can go ahead and push them out right now. There it is. Okay, so you got these little plastic retaining clips, push pins, and that holds this middle piece in. We'll pull it out in just a moment. I want to get this board out though, because this board is pretty cool. I got like a little spot right here where I can kind of pry up on the bottom a little bit. And these two spring-loaded arms right there. They create some sort of preload. I don't know what for, but it's pretty cool. All right, and there is that little, you gotta be really careful, because on the bottom side, you see this cable? It comes up and it's super tight. So I'm just gonna go ahead and very carefully push it out with this driver. There we are. Okay, okay. Nice. All right, so this guy's gonna have to sit tight. Let's go over this part. Let's see what's going on here. So those are the two clamps for preload. Right here are the two levers that I talked about. And these two levers, there's a whole bunch of little slits in them. You can almost see it right there. You see all the little lines? Now usually when you have that kind of flag, you shine a light through it, and as this moves, it counts pulses. I don't know if that's exactly how this one's being used. I would assume so. Somehow they're counting pulses to know distance of travel. Okay. Here are those two sensors that I mentioned. I do believe that these ones are ultrasonic sensors. They detect bubbles or fluid out in the IV set. Yeah, these preloads are wicked. The board down here, see how it's shiny like that? That means it's conformally coated. It's coated to protect it from moisture. Look at that. It's neat that they took that extra step. Right here's a couple little potentiometers, and right over here are a few potentiometers. You see them? They have some that do not have, what is that? It's like nail polish. They put on there to detect if somebody's tampered with it. Also acts like Loctite. But then they've got a couple of them here. It says DA and PA. I wonder what those are for. And then over here, I've got DP and PP. And then right here, on this side, right under the springs, I've got PGN and DGN. I'll try and figure out what those are later. Interesting. They took some extra measures to make sure that this guy isn't affected by corrosion. This is obviously where the brains are for this device. Yeah, I would say that this one here is the brains or the communications board, and this other one looks like a power supply. Like it is the motor driver. We'll see. Okay, so that board, let's put it off to the side. I have 3 stepper motors in here. You can see all 3 of them are right here off this little offshoot. And let's see, what else can I take apart on this guy? Yeah, that guy's trapped. You have a much better view of those spring-loaded contacts that I said from earlier. Huh. That's interesting. Those actually look like scales, like load cells. I think those are load cells, guys. In other words, it's detecting pressure. These guys right here are detecting pressure pushed down on it. Those look like load cells. They're just tiny. Absolutely tiny, guys. Can I get them out? Let's pull them out. That looks so cool. All right. And this, wow, these guys love this spring-loaded plastic. So right over here, I've got a retention, and over here, I've got a retention. So all you gotta do is squeeze them in a little bit, and this whole card should slide up, like so. I've got this ribbon cable still connected down below. Comes down here, and it comes all the way up here. That's that cable that I had to disconnect at the very end from this board. That gives even more credence that one there is the measurement board, because if these are load cells, then it's measuring pressure. All right, there we go. Let's pull them off. What are those? I don't know if those are load cells or if they just detect when something's inserted. If you guys know, let me know, man. They're thin strips of metal with 4 contacts, but it looks like there's multiple layers. You see them a little bit better right there. Maybe not too much better because this camera is not good. That is fascinating. They could just be electrical contacts, and when both those pins are pressed in, you have 2 physical connections that say, hey, I'm loaded. That could be it. Hard to say, guys. They might just be electrical contacts if they're not load cells. At this point, I don't know. I'd have to take them apart under the microscope. They might just be electrical contacts. All right. I've got a little rocker arm right here. Spring-loaded pins right there. See that? So this guy here will pop out. I've got a pin right here. Spring-loaded pin. You can see it. Have no idea what that's for. Not yet. Got some clamps that are holding some things down. This one over here, it's holding the motor down, or the motor board. Yep. Okay. So this whole thing is being held down. Let's see if we can get it opened. And I might as well just go ahead and disconnect every one of these motors too. Interestingly enough, if you're not watching where you disconnect these from, you could mistakenly connect them to the wrong socket. I would think that they'd be keyed or they'd have a different pin out or something. They're all 6-pin. That means you could accidentally mix up the motors when you put it back together. And I could only imagine the chaos that would be if you're actually driving the wrong motor. All right, let's see, what do we got? I do have a nut driver over there. Probably should use that, huh? Is that not the right size? What are the odds? It always helps to use the right size nut driver. Okay. There's also a bunch of these, I don't want to say crushable washers, but they're spring-loaded washers. Okay, I'm getting too many tools up here, folks. Okay. And that should be securing the board at this side. Okay. You can see the clamp that holds it on there. And I like that it's slotted like that, so it just kind of releases. They put a lot of thought into this design, folks. It's over-engineered. I have a feeling that it's European design based on how complex it is, unnecessarily. I do believe that these pumps were probably designed 20 some years ago, so that might explain some things. So we got a plastic latch right here, and I have one on the other side as well. Yep, right there. Oddly enough, the polymers that they used in this are not that delicate. Like, you can see me prying, I'm not being that gentle. I haven't cracked a single one of them yet. That's testament alone to their materials and their molds. Can't believe I haven't cracked a single plastic yet. Okay, so this guy is really being held in tight. I've already released this piece. It should just slide out, but it's not. Why is it? Oh, there's some more springs in there. That kind of sucks. Okay. Well, I'll tell you what. Let's just pull some motors. There might be some sort of drive linkage or something that's holding it down. Okay. Yeah, that motor's got like a coupling or something on it. It's being held in pretty good. There's some really interesting choices. Like this motor right here, you can see that it's got this spring-loaded latch, and the motor turns a few degrees and it releases. So if you just put a pry tool under this guy against the spring-loaded latch, it can rotate and the whole motor can pop out. It's fascinating how they design it. You see it? See, I rotated that, unlocked it. Now it comes out, and look at this thing is so over-engineered. You guys probably had no idea that this thing was this complex. Who designed this? This is wild. Look at how delicate that part is. It's made out of some sort of composite. It's got an eccentric cam. It's got an offset arm right here, hooks up. So it's doing multiple things. I just pull this guy out. There we go. Now I still have this motor. I've got one of those rocking arms right here. Another one. See it? It's got spring. There's a stainless steel spring right here. It's retaining it. I got this piece which can pop off. Ta-da! Yeah, 2 stainless spring arms. That's wild. It seems like they spent way too much time, energy, and money designing this pump. The crazy thing is these pumps don't fail at the motor that often. They might not pass calibration, but you can see why. There's so many moving parts. Of course it eventually won't pass calibration. And one of the main things I said earlier is some of the lubricants they chose to use for some of the moving parts. Those lubricants are drying up and they're getting funky. So from what I can see, this guy right here is attached to the motor on the other side. I've still got those plastic clips that are holding it together. Okay. It wants to spring apart. You see that? It wants to. But it's being held captive. Like there's a screw or something in it. Okay. You see a fastener maybe right there. I've got one screw right here by the motor. Right there, see it? Okay. That one screw was obviously holding it together somehow. Yep, this is all loose. This one here is being held by this clip. It's that one little screw right there. Just keeping it from popping apart. I keep fighting these stupid clips. All right. Still seems like there's something in the middle that wants it to stay together. That screw. I had to take it all the way apart. Wow, there's so much going on in this pump. What is the deal? Look at this. Okay, so let's go over what we're seeing here. So we have one optical interrupter here, and that's for something in this direction or in this direction. Then we have one right here that's counting pulses on the rotation of this stepper motor. So it's counting 2 pulses for every single rotation. You have a little armature right here and a little coupler. So you can see the coupler mates up down here to a coupler down there. This is obviously the driver board, folks. So you can see the incoming power. It's going to receive its power and its data signals. It has a large ribbon cable right here that connects to your computer, the measurement board. This board right here is got a lot of your drivers. So it's going to probably be counting pulses and driving a certain number of pulses for what's being requested from the measurement board. That's what I'm assuming. All right, don't shoot the messenger, folks. Right here are your 3 motor outputs. And let's see, what else is going on with this bad boy? It's got this very heavy shield on it. And I think that's because when you have these drivers are very noisy. So I think that is not a heat shield by any means. You can see it's offset and it's held by double-sided foam. I think it's a noise suppression shield that's suppressing these guys, which are buried in the middle of the pump, from any of the electronics, because you don't want any other inductors or any other components to be influenced by these guys right here. That's absolutely amazing. So here I am prying up on that shield. It's really stuck on there. You can see stuck on there with that double-sided foam. It doesn't really serve a real function. So here the stepper motor is very stout. Like I can barely turn it. You can see the 2 flags. There is a 3rd optical interrupter right here. Okay. Now they use another one of those, what is it, 8th turn. This time it's captive on this side. You can see that there's a spring-loaded mechanism right here. So all we have to do is lift this ear up a little bit and get it past the retainer, and it will turn counterclockwise and unlock. Let's see if we can do that. Is it going to be easy or hard? Not too bad. So I grabbed this exposed ear over here, and it was able to unlock the other ear. Careful, come on, careful, careful, careful. Okay. So This guy, you can tell that there is some goo on it, and that is old lubricants and wear and tear. Like some of that is dust from some of these composite. They're just wearing, you know, friction over time. So these pumps are going to have a life expectancy because the very limited amount of lubrication. Yeah, take a look at that. That's not graphite, folks. Nope, that's way too chunky. That is composites that are wearing on each other. Wow. Okay, got two stainless steel springs right here, and these two rockers right on the cam that is on the output shaft of the stepper. See that? Way over engineered, folks. I have a rocker right here, and it looks like it's got a little bit of grease right there, so that and that right on some cams. And this right here is that worm drive, or is it a worm drive? I don't know. Maybe it's not a worm drive. Let's see. When I rotate it, what happens? I need my large flat blade. So I'm gonna stick my flat blade right here and give it some rotations. What? Okay, I'm a little confused. There's an outer collar right here. So it rotates the whole square, not just not just the middle part. It rotates the whole square. You see it? And it is on a worm drive. See how it goes in and out? Right here. See how it's coming out. Let's see if I can keep going. Let's get it all the way out. Come on, you. There it is. There it is. Okay, so it's just a threaded nut, basically. This guy's a threaded nut. There is some old lubricant, again, down inside it. You can see it was white lithium grease at one time, but down inside it, there's a very dark, gooey substance. So that white lithium grease is just wearing out. So this right here is the plunger that actually does the pumping. It's very specific. There's a bronze oil bushing that it rides on that keeps it linear, nice and smooth. And there's that flag right there that detects when it goes all the way out or when it goes all the way into its home position. It's, I think on this one, it's all the way in. So it goes all the way out to push the fluids, and it goes all the way in. That's at its home position. So it has to be at the home position when you open the door, because that way there you can load the set without opposition, right? You gotta be able to easily load the calibration set or the infusion set. Okay, I'll tell you what, I really want to take a look at that threaded rod. That means I gotta pull this Jesus clip out. You guys are probably wondering why I call them Jesus clips. That's an old technician thing. They call them Jesus clips because when they shoot across the room, if you're not prepared for it, you go, Jesus. You can see the Acme threads right here on the rod. Those are Acme threads because they're a square thread, whereas like a taper thread or standard thread is pointy. Precision machined, of course. You can see they actually have it molded to the stainless steel piece. See that right there? That's not held in by a pin or a set screw or anything. It is molded or threaded in somehow right there. Crazy. Absolutely crazy. And another interesting thing is, see how this comes up in locks? Now I'm curious if that comes up in locks like that when you open the door, because that way there, the plunger can't move, right? Or if that's the braking mechanism, because you know when it ends the infusion, if it pulls that lock out, so that it can't rotate and it can't distribute. I don't know what they call it, like a free run guard. You know how like some infusion pumps, they clamp the hose so that it won't free run. In other words, keep distributing fluids to the patient when you don't want it to. I wonder if that's what that is. Kind of curious. But it's clearly some sort of lock. But let's see. We have, is that a bearing? It sure is. Take a look at that. Actually, good on you guys. I was kind of expecting another oil impregnated bronze bushing, but nope, they put a proper ball bearing in there. See that? There's a couple precision washers, one on each side, and that's what it runs on. But it has a proper ball bearing inside it. And, you know, I'm not going to take the levers out or anything because I don't really think that there's a real need to. They just rock, they ride on the cams, they do their thing. These spring-loaded rods obviously actuate something in the infusion set. To be honest, I have never loaded one of these pumps up and run it. So normally when I look at a disposable infusion set, I look at all the crevices and all the precision measurement points, like the pressure transducer point and stuff. And, you know, these pumps here, I've never had the opportunity to work with them, and I just tear them apart. You know, Alaris is my bread and butter, B-Bronze and some of the other pumps. These guys here, I've got people that work for me that are specialists in these pumps, and they know every little crevice of calibration for them and whatnot. But I myself, I do not. Interesting, fascinating little pump. That, guys, the bill of materials on this pump module alone is insane. Guys, this is an absolute mess. All these tools, I'm going to treat them like they're contaminated, and I'm going to have to go tomorrow and clean all this stuff properly. This pump will never be reassembled, folks, so if you're like, ooh, you're being too rough on it, I don't care. Guys, this is for entertainment purposes only. You can see clearly that this pump is still contaminated, and because of the lubricants, because of the sticky lubricants, they're wearing down, because of the extra wear and tear on the composite parts, that's creating a gray type of mixing with the lithium grease. Not worth it, folks. This pump is never going back in business. So it is what it is, and I hope that you found this interesting. Never tore one of these apart before, and I'm actually pretty glad that I did. So thank you all for watching, and stay tuned. I got some other crazy stuff I'm going to be doing this weekend, so hope you all enjoy.